Unlike ionic compounds, molecular compounds are made of molecules. On this slide, we see the space-filling models of the molecules of water, ammonia, and methane. For water, the red sphere in the middle represents an oxygen atom, and the two white spheres represent hydrogen atoms. For ammonia, the blue sphere in the middle represents a nitrogen atom, and the three attached white spheres represent hydrogen atoms. For methane, the middle black sphere represents a carbon atom, while the four attached white spheres represent hydrogen atoms. Below each space-filling model is a Lewis dot structure. Each atom is represented by an elemental symbol, capital O for oxygen, capital H for hydrogen, capital N for nitrogen, and capital C for carbon. The lines represent two shared electrons or a single covalent bond. Notice that oxygen has two single bonds, nitrogen has 3 bonds, carbon has 4 bonds. We will soon learn what the dots on oxygen and nitrogen mean. Non-metals tend to have a favored number of covalent bonds. This graphic from the textbook, figure 4.3, summarizes the typical number of bonds. Hydrogen and fluorine always have 1 bond. Boron tends to have 3 bonds, but can have 4, while carbon always has 4 bonds. Nitrogen tends to have 3 bonds, oxygen tends to have 2 bonds, fluorine, I said, only has 1 bond, and the noble gases generally do not form bonds, although there are some exotic compounds made from xenon. Non-metal members of the same family tend to have the same number of bonds. However, third row and below can form more bonds than the nonmetals in the second row or period.